visualization using SketchUp. Actually, modeling, rendering, those two major parts are the most important thing when we are dealing with some 3D building and 3D graphics. But actually, today's focus is a little bit more on geometric modeling, okay? Not rendering or visualization. But anyway, whatever you create, you model, you have to model from scratch, from nothing, and then you can visualize them. So let's move on and let's tackle some issues in geometric modeling. I know in lab exercise hours, for lab exercise 1 and 2, for the first and second hour, you are working on that. But anyway, now it's time to close SketchUp, okay? And then go back to SketchUp modeling. So please keep your eyes on the course material, okay? We are in 11th week, but actually AutoCAD drafting, especially for 2D, we're gonna deal with next week. AutoCAD drafting and some visualization issues. But today's topic is anyway SketchUp geometric modeling. And next week, we're gonna have midterm exam. I'm gonna tell you and I'm gonna give you example questions for midterm examination. Okay, lab exercise 1 and 2. You already did something, but let's get back to course material. 3D graphics, modeling basics. For making 3D geometry, modeling 3D object usually very time consuming and very tedious because we have to control geometric components, elements in 2D or 3D. Creating an object, it's very hard to do except making primitives. But actually in SketchUp, making primitives is also another challenge because there is no primitive object actually in basic interface of SketchUp. But we're gonna deal with it one by one today and modify them. It's very time consuming and iterative process. Primitives, they are here. Cone, cylinder, wedge, sphere, torus. Actually in general 3D software such as 3D Max, you can simply click torus and click reduce, type reduce, and dragging it, and then you can easily make it. But in SketchUp, there is no way to create those primitives, but you can easily draw and make them, and we're gonna demonstrate it using basically using extrusion. What is extrusion? It's the easiest and the most straightforward way of making 3D object using 2D section profile, okay? In 2D XY plane, whatever you create, circle or some polygon shape, donut shape, rectangle shape, whatever, they can be extruded using Z-axis. In SketchUp, we have such function. Okay, please open empty one of SketchUp. Blank SketchUp, please. And actually, you know how to handle SketchUp geometric modeling using some fundamental interface. But let's take a look at how to make those primitives. Making primitives, sometimes very easy when you have this kind of icon, but in SketchUp, there is no such icon. Instead, change view. Actually, we don't need to change camera view right now. Simply create a box. And this one, push-pull, will generate this kind of box. This is fundamental primitive. But what if you click this edge and move this one to the end. This one, another primitive wedge, okay? How about cone? The same as rectangle shape, you can make it using simple push-pull. This is cylinder, okay? And to make a cone, what you need to do is control its sub-geometric component. Select this one and type S. S means scale. And you can change the scale of the top one, but click Control, okay? If you click Control, center point gonna be fixed so that you can control like this way. At the end, you can make certain type of cone which has different radius, top to bottom, okay? Box, pyramid, all same. But interesting thing is torus. Let's talk about torus. I think you may learn how to use follow me 3D making option. But let's take a look at this one. Change your camera view, parallel projection, and top view, okay? And let's draw a circle. But actually, circle side default is 24, but type 100 to change bigger number of segments so that you can draw much better circle like this, okay? Okay, now we have a circle. And please change your view. Standard view, front view, okay? And let's draw another circle here. Not that big one, okay? This is circle we just draw on top view and another circle in front view. So if you drag it like this way, now we have one 2D section circle and another circle. But we need to remove this plane so that we just have line, pass. What you need to do is click this one, follow me, and click here to, okay. Again, click here to somewhere here, okay. Do you see what happened? Okay, follow me. If you want to make this one kind of join, click certain endpoint to certain endpoint here, midpoint. Okay, take a look at this one. So let's try it again. Click follow me, follow this place to, again, to this one, here or there, okay? That's it. Using follow me function, you can draw your 2D section profile exactly as it literally means follow the circle line, okay? So that you can create this kind of tube, primitive torus, okay? Actually, in the lab exercise hour, when we get back to lab exercise hour, let me show you some more examples. This is just for your information, for making and handling primitive object, okay? Okay, we have more time, so let's get back to the course material, please. What's next? What's next in making 3D geometry? It's revolving a surface. Another 2D geometry we need. But at this time, this is another 2D geometry, section profile. But at this time, we have an axis. Using that axis, we're going to revolve it. The tool name in 3D Max or some general tool is lathe, so-called lathing, revolving a surface. Take a look at this surface. The surface can be revolved, followed by this axis line. And then you can create this kind of object, 3D object. This is second way of creation in 3D using 2D, okay? The third one is actually the most important one, sweeping. Sweep a section profile onto a polygon path. Actually, we did this one just now, okay? We just drew a path, and we drew a section profile using circle, 2 circles, but smaller one gonna be followed by moving around by this another circle guideline. This guideline is path, okay? Number 2, path. Number 1 is section profile, so that you can create anything. Take a look at this 3D Max interface. We have section profile and path, so that you can generate this one. Simply think about some interior finish, such as that kind of molding on the ceiling. That kind of molding elements can be easily generated by this sweeping function, okay? We're gonna deal with this one again in lab exercise after the lecture. What others? If you invent and propose some more additional and some even smarter way for making 3D object, that's going to be really great, because actually making 3D object, I mean the classification of making 3D object are kind of limited. Just 5, 6 ways, not that many. Some others, skinning, Boolean operation, so-called constructible solid geometry. So from 2D geometry to 3D model, fundamental method is extrude. If you type extrude even in AutoCAD, you can make this kind of 3D, okay? In 3D Max, of course, there is extrusion and SketchUp. Fundamental function of push-pull in SketchUp, that is extrude. Next important thing is loft. The term loft is 3D Max term actually, but sweeping, I told you, and follow me function in SketchUp. Revolving, lathing is also very important. When you draw this kind of 2D drawing, you can edit, modify this kind of 2D section profile, and you can revolve it. Just updating this geometry, you can go back and edit. And then you can update 3D object in that way. So making 3D object, you should know where we are, what kind of methods are available, what you have to do, making primitive, making a box and iterative modification. That's one good way. Or you can create something different way. Today, I would like to show you something different way. That is Boolean operation. Take a look at this base-like object. This is a box. Another smaller box inside of it, and that is B. The bigger one is A. What if you operate A minus B? And then you can create that kind of geometry, okay? That's fundamental. Union, intersection, cut, minus, plus, and so on. Let's take a look at this Boolean operation in 2D geometry. Rectangle shape A and circular shape B. A not B means A minus B, so that you can generate this kind of geometry, okay? Very easy and straightforward. B not A means B minus A. So A minus B, B minus A, if we plus them, we can generate this kind of thing, A XOR B, which means A minus B plus B minus A. How about intersection? You know this one, A intersected B, this part. Of course, union part returns entire area for those two different objects. How about you perform this one, Boolean operation in using 3D geometry? A and B, at this time, they are 3D object, A minus B, A union B. Totally different object from those two primitives. So this kind of object also can be derived from primitives. Important thing is those two objects are primitives. How to create this kind of shape, this kind of 3D object? This is not a totally new. They are all kind of operative, constructive, solid geometry. Let's assume that A, box shape, B, sphere, C, cylinder, and different type of cylinders, D and E. A intersection B returns this one. C union B, D and E union returns this one. So simply this one minus this one. So the final operation can be represented in that way in mathematical form. Okay? So that kind of geometric forming, geometric shape is another way. Constructive solid geometry. As we discussed before, SketchUp is non-solid. I mean, it's surface-based model. But thankfully, it supports some solid tools. On the tools, there is a tool named Solid Tools, and we can use some subtract, union, and some more additional operation. Something like this, okay? Here is an example, and let me show you what is that. We need to make our own geometric shape in 3D and make them all components. You have to make something components, not to lose some subgeometry, and subtract them. This is very useful, and let's try to make this. Please open another empty. Please open another empty one. SketchUp. At this time, we're gonna deal with some Boolean operation. Solid tool, even if it's surface-based modeler, we can do something like solid modeling tool. Okay. Okay, let's create a simple box. Here it is. Okay, in this status, you can select one by one the components, but at this time, it's not good. If you finalize your object, it should be turned into a component. So select them all, okay, and click right button, make it component. Your name, that's okay, but let me use some default name and create. So now this is a component. Okay, what if you want to create some holes? Something like this one. How to create this hole? Actually, you can make this one by some kind of freehand drawing and extrude it. But another way, simply extract it. What we need to create is some object. So let's draw something here. Okay, at this time, let me just simply draw like this one and make it 3D, okay? And you have to select them all and make another component. Create. So let's move this one to middle of this place. You can click S and control the size or something else, whatever you want. Okay. Take a look at those two objects. There is no edge line, which means that those two objects are totally overlapped. They are different, two different objects. What if you minus this one from this one so that you can create some holes? Let's do that. Okay, click nothing and click tools, click solid tools and subtract. This one can be 1 and 2. Okay, reverse direction. This one should be 1 and this one should be subtracted from number 2. Okay? Do you see this one extracted, subtracted? Control Z. What if you want to create some more holes or some subtracted things? Click Control and move, multiply 2. You can move this one to somewhere here and type S. Okay, now we have some more objects and another one here. Select nothing and tools, solid tools, subtract and number 1, number 2, click nothing, number 1, number 2, something like this, okay? What if you want to make a union from this one? In that case, click tools, solid tools, union, and number 1 and number 2. Okay, please take a look at this one. Select nothing. Now you may find out edge lines here. Those two objects are not overlapped. They are integrated into this one. So 2 holes and this one union into that flat floor-like object, okay? This is very intuitive and straightforward way of making geometric shape, geometric components in 3D using solid tools, okay? Okay. We're going to move on, and I'm going to show you some more examples, demonstration. Let's get back to the course material. Let's get finished course material first, and then move back to lab exercise, okay? Next thing is, again, review of 3D visualization. Actually, today's lab exercise 3 and 4 in charge of making some visualization. Using V-Ray, this is a review, okay? Here I list up again rendering basics. It's all about lights, all about lights. We have lighting source, we have target object, we have camera. We have learned something about camera, but in SketchUp, it's not that critical. So what we need to know is some lighting source, except some default light, such as sunlight. We have to place our own lighting system. And the most important thing, your target object. it has diffuse, reflection, refraction, and so on. Left one has some photorealistic, but this one doesn't have global illumination features, because even though this wall has green color, it's not affected. Green color gonna be affecting into this entire environment thanks to some global illumination, ray traced rendering feature. So here I list up all about rendering. So target object has object surface, object interaction. Object surface has diffuse, reflection, refraction, and so on. And diffuse has color, intensity, texture map. Also reflection has color, intensity, texture map. Very structured interface and structured concept. You need to know how to control them using this kind of different interface. At this time, this is V-Ray interface, but terminology and mechanism almost same to other renderers or some different issues when we are dealing with rendering. On the diffuse, there is color and some texture map option. I told you all about lights. Something happened exactly same to real world, so that you can see photorealistic rendering outcomes, outputs. Reflection, we have to know how to control that reflection option, which simply means white, 100% transparent, black, 100% opaque. Glossiness, different numbers of reflection glossiness returns this kind of different effect. Refraction, IOR, index of refraction, shows some different numbers, and they return very different effect while we see it through this kind of translucent object. So we have to know some representative IOR, such as glass, water, and so on. Emissive, it's another type of lighting which has self-illumination. We have to know its color intensity and double-sided or not. So they are all some review aspect of rendering. We just keep the lighting options, but we're going to deal with that in lab exercise hours too. So let's move on. Lab exercise 1, 2, we already working on, and 3 and 4. And some additional thing we have to deal with, okay? Let me finish the lecture and we have a short break and then move on to rest of things, okay?